Intro Algebra Lesson 3-3A. We've now spent some time working with one-step equations involving inverse operations to solve, with addition, subtraction, multiplication, and division, and we always want to think about how can we get the variable completely alone. You might want to think about the normal order of operations, which is to deal with any parentheses, exponents, multiplication, division, addition, and subtraction, and we want to do that in a reverse order, which means we would take care of the addition and subtraction, then we would take care of the multiplication and division, and then work our way inside the parentheses. So we want to completely reverse the order of operations if we can. This is going to be multi-step equations, so there's going to be more than one step, and we've got to think about what the normal order would be. So here we have 1/2 x minus 5 is equal to 10. Again, there are a number of ways of solving equations. We're going to concentrate our efforts on just one method right now. We would like to get x alone. That's our objective. In order to get x alone, we've got to get rid of the 1/2 and we've got to get rid of this minus 5. Most common mistake is people try to get rid of the 1/2 first. Remember, normal order of operations would be to take care of multiplication, division, addition, and subtraction. That's normal. This is the normal method. But we are solving, so to solve we have to go this way. We've got to take care of any addition and subtraction first, and then take care of any division and multiplication. So a quick adjustment to the appearance of the problem would give us plus -5. According to solving, we're going to take care of addition and subtraction first. So I want to take care of this addition first. The only way I can get rid of this -5 is with a positive 5. And our rules are still the same. Whatever you do to one side of the equal sign, you must do to the other, which means I don't want to come over here and add 5. That's not to the other side of the equal sign. I want to add to the other side exactly the same thing I've done on 1. So now the -5 and the positive 5 are opposites. They cancel each other out. And I'm left with the 1/2 x is equal to 15. So what I've done is I've taken care of this addition and subtraction part first, because solving is reversing the order and doing the opposite. Now I need to take care of any division or multiplication, and in between the 1/2 and the x is multiplication. We know that anytime we want to get rid of a fraction, we can multiply by its reciprocal. So I will multiply by 2/1, because now I have a 2 on the top and the 2 on the bottom. I have a 1 on the top and a 1 on the bottom, so they'll all cancel out, and x will be the only thing left. But what I do to one side, I absolutely must do to the other. I did not write that 2 as a fraction because this wasn't as a fraction. I could have. Now the 2's cancel, the 1's cancel, x is alone, and 15 times 2 is 30. You can still check your answer by plugging it back in just to see if it works. What is 1/2 of 30? 1/2 of 30 is 15. What's 15 plus -5? 10. It works. Now I'm going to do it incorrectly for a moment, just so you can see. 1/2 x plus -5 equals 10. This is the wrong method. Multiplying by 2/1, multiplying by 2. Those would cancel. X plus -5 equals 20. Add 5, x equals 25. That's what happens when people do the inverse operation incorrectly, and they take care of the multiplication first instead of this addition or subtraction. If you test that out, what's 1/2 of 25? 12.5. And what's 12.5 plus -5? Positive 7.5. It doesn't equal 10. It doesn't work. This method is incorrect. You've got to be very careful about that. That's why I listed the normal order of operations going down. To solve, we want to go the other way. This is the correct method. Let's try another one. Now in this problem, there's actually some like parts that we want to first combine. Don't get caught up into playing what I call the shuffling game until you've looked at, are there any parts that you can put together? Certainly these both have x's. The 17 does not have an x, so it has no business being added together with these two. But these both have common like parts, so we can add them together. 2 x's and -9 x's. That's going to make a total of -7 x's. Let me show you what a couple mistakes are that people make. Sometimes I see people add 9x here and add 9x here. That completely breaks the rules of what we do to one side of the equal sign we do to the other. We don't want to play the shuffling game with these two right now when we're putting them together. They're already on the same side, just combine them. So instead, we will add these two together and get negative 7x plus 17 equals negative 4. At this point, we are in the exact same situation we were here. We have something times x plus a number without x equals another number without x. All right? Normal order of operations, multiplication, division, addition, subtraction, that's normal. We want to do the opposite, which is to solve. We want to reverse it. Again, we don't want to take care of this multiplication, we want to take care of this addition. So what I like to think of is this stuff has x's, this stuff does not have x's, this stuff does not have x's. The stuff without x's needs to get together. So I got to get rid of a positive 17 by adding a negative 17. Be careful you don't just subtract 17. People come over here and subtract 17, they get negative or positive 13, which is clearly the wrong answer once you see it correctly. We should have negative 7x is equal to negative 21. So a very common mistake, these people end up with a positive or negative 13 because they don't deal with signs correctly. Watch that. Now I've taken care of the addition and subtraction. So according to my order of operations, I've taken care of the addition and subtraction. Next I want to take care of any division or multiplication. There is multiplication. The opposite of multiplying by negative 7 is to divide by negative 7. Those cancel out. A negative divided by a negative makes a positive 3. You can test it out. What's 2 times 3? 2 times 3 is 6. What's 6 plus 17? That's 23. Negative 9 times 3 is negative 27. If you add negative 27 and then positive 23 together, you will get negative 4. It works in the original equation. That's how we know we're right. Alright? Again, very similar to the last problem. We'll do some adjustments. Plus negative 3x plus negative 8. And we need to recognize we have some like parts. 7x's and negative 3x's combine to make a positive 4x plus negative 8 equals positive 24. Again, the normal order of operations is multiplication, division, addition, and subtraction. So when we solve, we want to go up. We want to take care of any subtraction or addition and then take care of any division or multiplication. So I got to get rid of this negative 8 by adding 8. Those cancel out. 4x now equals 32. Now I can take care of the multiplication and division. The opposite of multiplying by 4 is to divide by 4, which gives us a final answer of x equals 8. You should be able to test this answer anywhere in the problem and it should work. In fact, 4 times 8 is 32. Good. 4 times 8 is 32 plus negative 8 is 24. Good. 7 times 8 is 56. Negative 3 times 8 is negative 24. Negative 24 plus negative 8, that's negative 32. If you add 56 and negative 32 together, you end up with the 24. So it does work. It works in all stages of the problem. Because by doing this to one side, I also do the other, I'm not changing the value of the equation, I'm just changing the appearance of the equation. Alright, even more complicated. Now I'm going to show you a trick on this one, because it's not so much fun when there's a whole bunch of these fractions. Although you could just go ahead and take care of them because they have common denominators. So it's certainly up to you. If you want to take 2x and add negative 1/5 x, that'll work. If you would rather, you can multiply every single part of this problem by a common denominator of 5, and you won't have to deal with any of those fractions. So let's just do it first of all by normal common, by putting these together. 2/5 and negative 1/5 leave you with 1/5 x plus 9 is equal to negative 1. So, our normal order of operations says multiplication and division, then addition and subtraction. We're reversing that, so we're going to get rid of the addition first. In other words, the stuff that doesn't have x's needs to get with the other stuff that doesn't have x's. Now you have 1/5 x is equal to negative 10, because negatives plus negatives make more negatives. We get rid of a fraction by multiplying by its reciprocal, and we are left with x equals negative 50. So that should be the answer. Now if I go back up and I take this original equation, I'll clone it. I'll take it down here. And I'll try it again. This time I'm going to multiply everything by 5. This is plus negative. But I'm going to multiply everything by 5. I'm going to multiply here by 5, here by 5, here by 5, and here by 5. Everything's going to get multiplied by 5 because that's the common denominator. These have denominators of 1. I'll be left with 2x plus negative 1x plus 45 equals negative 5. These are like parts. You can put those together. I get 1x plus 45 is equal to negative 5. Now that's 1x is the same as x, so I'll add negative 45 to both sides. And I get the final answer of 1x equals negative 50, or x equals negative 50. The exact same answer that I had before. So whether you decide to multiply the entire problem by a common denominator to wipe out the fractions so you don't have to worry about them, or you deal with the fractions throughout the problem, it won't matter. It's a nice way of dealing with it. Last one. This one has grouping symbols in it. We need to take care of those grouping symbols. I can't add this 4x to the 12. And I can't add this 4x over here to get rid of it. And I can't add 4x to this x because it's inside the parentheses. And I can't add x to minus 3 because they're inside the parentheses and they're not like parts. But I could take and adjust this to plus negative, and I could distribute the 12. In doing so, I now have 4x plus 12x plus negative 36 is equal to 28. And now the problem is identical to this situation where you have some stuff you have to add together, or this situation where you have like parts, or this situation where you have like parts. They're all the same. So I'm going to add these two together. 4x's and 12x's make 16x's plus negative 36 is equal to 28. Again, my normal order of operations would say to take care of the multiplication, but I want to get the stuff that doesn't have x's together. So I'm going to add 36 to both sides. When I add 36 to both sides, I get 16x is equal to 64. My last step is to get x completely alone. The opposite of multiplying by 16 is to divide by 16. Divide both sides by 16, and x is equal to 4. So I get a final answer of 4. If you test it, 4 plus negative 3 is the same as 1. 12 times 1 is 12. 4 times 4 is 16, and 16 plus 12 makes 28. It does work in the original problem. You must think about the normal order of operations to what you would normally do, and reverse the order and do the opposite if you want to solve. Inverse means to undo.